Okay, what we're going to do now is we're going to break into a database. Actually, we're going to make the database and then we're going to break into it and then we're going to fix it. Okay, and though this is a very easy attack, it's an attack that happens. And it's called SQL injection. And I'm sure we've talked about it before. I've talked about it at the beginning of this week, and then it's obviously come up in the learning. But we're going to do this in real time, as it were. Okay, now, if you notice, we call this little Barbie tables as a name, and we do that as a kind of joke because there's a kind of well-known nerdy comic called XK's CD, and if you haven't come across it, I suggest you go and find it because it's quite funny and quite computer sciencey. Anyway, there's one famous one in which uh, a child enters a school and enters a database, and his name is this thing here. Now, and then that goes into the database, and drop table is an SQL command which says delete the whole table irrevocably, and what table is deleting is students. It ends up deleting the whole students database, and it's all because the child has this weird name. And as we talked about this before, it's the confusion about SQL commands and names, and we'll get to that now. So we're making a database that we can break. I'm not going to labor the point of how to make a database, but we're making a very, very simple database. And it's got it's got a table with four users in it. And the users have names, and the users have passwords, and they're pretty poor passwords, let's face it. Most of these are really awful. Password 123 is about as bad as you can get, and they've got roles. And then it makes this database. So let's make the database. We've made the database now, and you see it's got these four people in it, and we don't get their passwords because that's private. Okay. Now this is the login function we're writing for our database, and the problem is that we're doing all this picking up the usernames and passwords within the query. People do write code like that, and it's not a good idea. So I'm now compile that. So, but with that, all right. Let me just. The password looks fine as long as you got the right password, and if we have the wrong password, it doesn't work fine. So that we've welcomed Alice as a journalist to our database, and now we failed by changing the password, and so it ought. But that's fine. But that doesn't mean it's okay. It means it does seem to indicate it's probably okay when things are right. But what vulnerabilities have we got? So here's one. And we're trying to log in with this. Well, let me think about this. This is the name, and this is essentially the password. And the thing is that the password, it's this thing here. That's the real password, and that just turns off the password. That's a comment. So it kind of turns off the password thing. And this thing here is always true. It says equal or 1 equals 1. 1 always equals 1. So this will just match. It will be read as code that's true, so it will match with everything. So it's going to match with all the users in the database. Now, if it does that, what's going to happen? So here's that's what it's matching with. And when we've done that, the problem then is we are now an administrator because it matches with everything. So you end up taking the role of the first thing it matches with, and the first thing it matches with is administrator. We're now the administrators in this database, and we really didn't mean to be. I mean, well, maybe we meant to be if we're bad actors, but I mean, this is not supposed to let us be the. This is not the administrator's password name, which is admin or something, and certainly isn't his password, which is some whatever it was. It doesn't matter, but certainly not there. And so this is not supposed to happen, and things can get even worse because the SQL injection can also call this union thing, which will get it across tables, and so we can get all the information out. So here's something that's just suggesting, well, we're going to print out everybody's passwords. So even though I couldn't get the passwords further up by just here out, here then now look at that, I've now got the passwords. So this is not great. So what am I going to do about it? Well, we're going to fix it by doing two things. The first will be enough, and the first is called having parameterized queries. So what we have to do is separate out with the user's input from the SQL. And we do that, and the really important thing is these question marks, which will only match as values, not as commands. So all of this it will never become a command. So that's all good, and the legitimate login still works. And well, it's not going to because the password's wrong. So let's see that. Logins failed, but if I get put the password right again, it will work fine. But now the injection attack fails. So if I try the injection attack, I get nope, 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 nope. So it doesn't work. The injection was treated as a literal username, and that's not going to help. The union also fails. Nope. Union injection was treated as a literal string. No good. Okay, that does it, but we're going to also put into something else. We're going to have the input check on we're going to check that the input is of the valid type. So we know we have it written down what sort of things we'll accept as a name. And if we get the kind of weird thing we had before, what's going to happen? Well, if we have the legitimate login, we'll get, okay, it's all right. And then it passes on and we get Alice and her password. But if we try this weird one, it says that's not an allowed pattern anyway. So just to recap that, we carelessly did the quickest thing you possibly could do to make a login. That leads you to a big vulnerability. It's a vulnerability that's cost a lot of people a lot of problems, and we got around it by parameterizing the queries and by input validation. And the other thing you can do is you can also give people limited powers. I mean, drop table should not be something that many people have the power to do, if anybody. So there we go. So the vulnerable version fell to 20 characters in the text box. The fixed version treats the same characters as meaningless string. That's the difference between a data breach and a safe system. And let's close off this connection. And I will see you next week at the beginning of next week, when I introduce the next topic.